Hello everyone, in this video we'll continue with Maxima and Minima. We'll do some more problem based on geometrical applications of Maxima and Minima. So we'll start with this problem. A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meter. Find the dimensions of the window to admit maximum light through the whole opening. So the window is in the form of a rectangle surmounted by a semicircular opening. So that means on the top this semicircular opening is there. Find the dimension of the window to admit maximum light. So that what should be the dimensions of the window so that maximum light comes through the whole opening. So the figure of the window will be like this, that is a rectangle will be there, then a semicircle on top of the rectangle. Suppose length of the rectangle be x and breadth be y. If length is x, the radius of the semicircle will be x by 2. So given that the total perimeter of the window is 10 meter, the total perimeter is given to be 10 meter. So now we have to find the dimensions of the window to admit maximum light. So we have to find the maximum area of the window. Maximum area of the window when perimeter is equal to 10 meter. So given perimeter equal to 10 meter. So now if we can find the perimeter of this figure, so suppose we take perimeter as P. So the perimeter means x plus 2y, here also y will be there. So the perimeter of this part is x plus 2y. Then perimeter of the semicircle, that is pi r. So it will become pi, radius is x by 2, pi r, and this perimeter is given to be 10. So this is given to be 10. So x plus 2y plus pi x by 2 equal to 10. So this is the perimeter which is given. Now from this we can find y equals to 1 by 2 10 minus x minus pi x by 2. So we can find y in terms of x here. So that is half 10 minus x minus pi x by 2. So that is equal to 5 minus x by 2 minus pi x divided by 4. So y equals to 5 minus x by 2 minus pi x divided by 4. Now we'll find the area of the window. Area of the window. Suppose let it equal to A. So that is area of the rectangle, that is length into breadth, plus area of the semicircle. So area of the semicircle will be 1 by 2 pi r square. R is x by 2. So 1 by 2 pi r square. So x by 2 is the radius here. So it will become xy plus pi x square divided by 8. So this is the area of the window. Now the question is to maximize the area. So we have to find the dimensions of the window to admit maximum light. So that means what will be the maximum area. So you have to maximize this area. So before differentiating, let us write in terms of x. So that means y we will write it as 5 minus x by 2 minus pi x by 4. That is writing y in terms of x, then plus pi x square by 8. So that will get simplified into 5x minus x square by 2 minus pi x square by 4. Pi x square divided by 4 plus pi x square by 8. So the area of the window is 5x minus x square by 2 minus pi x square by 4 plus pi x square by 8. So now we find the derivative to find the critical point. So this is a function of x alone. So there is only one variable here, that is area of a of x. So now we'll find the derivative. A dash of x is equal to 5 minus 2x by 2 minus 2 pi x by 4 plus 2 pi x by 8. So this is the derivative. 5 a dash of x equals to 5 minus, so that is equal to 5 minus x minus pi x by 2 plus pi x by 4. So now to find the critical point, a dash of x equal to 0. So that implies 5 minus x minus pi x by 2 plus pi x by 4 equals to 0. So that from this the value of x will become as x equal to 20 by 4 plus pi. So the value of x from this we will get it as x is equals to 20 by 4 plus pi. So now you find the second derivative. A double dash of x. A double dash of x will be the differentiation of this one. So it will become minus 1 minus pi by 2 plus pi by 4. So the differentiating this one, so it will become, it is less than 0 because it is independent of x, so it is always less than 0. So that means area is maximum. Area is maximum when x is equals to 20 by 4 plus pi. So when x is equals to 20 by 4 plus pi, y is equals to 5 minus 10 by 4 plus pi minus pi by 4 into 20 by 4 plus pi. That is substituting the values of x in here the value of y. So we get this one 5 minus 10 by 4 plus pi. So it's equal to 10 by 4 plus pi. The simplification you'll get it as 10 by 4 plus pi. So the dimensions of the window should be, the length and breadth of the rectangle should be 20 by 4 plus pi and breadth is 10 by 4 plus pi meter respectively. So the radius of the semicircle should be the half of this one, so it will be 10 by 4 plus pi. So these are the dimensions of the window which allows maximum light. So now we move to the next problem. Show that height of the cylinder of greatest volume which can be inscribed in a right circular cone of height h and semi-vertical angle alpha is 1/3 that of the cone, and the greatest volume of the cylinder is 4 by 27 pi h cube tan square alpha. So here we are inscribing a cylinder inside a cone. The height and semi-vertical angle of the cone is given. So then we have to find the maximum volume of the cylinder. So cylinder is inscribed in a cone. So here the semi-vertical angle is given to be alpha. Semi-vertical angle is given to be alpha, this angle, and height of the cone is given as h. So height of the cone is h. So these are the two things given. So you have to find the maximum volume of the cylinder inside the cone. So we'll try to find the volume of the cylinder. So before that, let radius of the cone cylinder be r and height of the cylinder be x. So now radius, let r be the radius and x be the height of the cylinder. So volume of cylinder is equals to pi r square x. This is the volume of the cylinder. Now we have to maximize this. So we have to get the maximum of this one. So before differentiating, we have to convert either r or x in terms of the given quantities, that is height of the cone and semi-vertical angle. So if suppose this point is taken as g, so g is already there, sorry, h. So this point is taken as h. So then ah will be equal to this will be equal to the height of the cone minus height of the cylinder. That is height of the cone minus height of the cylinder, h minus x. Now from triangle AHC, tan alpha, that is tan of this angle, will be equal to r by h minus x. So that means radius of the radius of the cylinder will be h minus x into tan alpha. So now we'll substitute this here for r. So this will become pi tan alpha square, that is tan square alpha, into h minus x the whole square multiplied with x. X is the height of the cylinder. So tan square alpha h minus x whole square into x. So now here this is alpha and h are given constants. So this is a function in x alone. So v of x is equals to pi tan square alpha h minus x whole square into x. Now we can differentiate with respect to x. So v dash of x pi tan square alpha. So this is using product rule. So it will become h minus x whole square, then plus pi tan square alpha into 2 into h minus x minus 1 into x. So that is using this, we are differentiating with respect to x and using product rule. Now we will find out the critical point. V dash of x equal to 0 implies pi tan square alpha h minus x whole square, then minus is here, so this can be written as 2 into pi tan square alpha h minus x into x equal to 0. So here pi tan square alpha h minus x is common, so that means it will come as h minus x minus 2x equal to 0. So that implies pi tan square alpha h minus x into h minus 3x equal to 0. So this implies h equal to x or h equals to 3x. H equals to x or h equals to 3x. So that is height of the cone should be equal to height of the cylinder, or height of the cone should be equal to 3 times the height of the cylinder. So height of the cone inside height of the cylinder, this is not possible. So this is the case. Now we will find the second derivative to check whether it is maximum or minimum. So v double dash of x, so this one only will differentiate pi tan square alpha. This again product rule, differentiating with respect to x. H minus x derivative is minus 1 to h minus 3x. Then plus pi tan square alpha h minus x into minus 3. So this is the second derivative. Now when h is equals to 3x, that is this critical point, h is equals to 3x, this will become less than 0. Less than 0 when h is equals to 3x. So that means second derivative is less than 0 when h is equals to 3x. So therefore volume V is maximum when h is equals to 3x, h is equals to 3x, or x is equals to h by 3. So the volume is maximum, volume of the cylinder is maximum when height of the cylinder is 1/3 of the height of the cone. So that is the first part. So the height of the cylinder is 1/3 of that of the cone. So height of the cylinder of the greatest volume will be 1/3 that of the cone. So the first part is proved. Now we'll find the maximum volume. Maximum volume V of x is equals to pi tan square alpha h minus x is h by 3, h by 3 whole square into h by 3. So this will come as pi tan square alpha, so h minus h by 3, that is 2h by 3 the whole square. So it will become 4h square by 9 into h by 3. So it will become 4 by 27 pi h cube tan square alpha. So this was the second part. So we got the maximum volume to be 4 by 27 pi h cube tan square alpha. Now to the last problem. A point on the hypotenuse of a triangle is at a distance A and B from the sides of the triangle. So a point on the hypotenuse of a triangle is given to be at a distance of A and B from the sides of the triangle. So now you have to find the maximum length of the hypotenuse. So you have to find the maximum length of the hypotenuse. So here P is the point which is at a distance. P is a point which is at a distance A from this side and B from this side. So here suppose this point is taken as M and this as L. So from triangle, so we have to find the maximum length of the hypotenuse. So length of hypotenuse is equal to AP plus PC. AP plus PC, that is the length of the hypotenuse, AP plus PC. Now we will write AP and PC in terms of the angles. So AP and PC. So from triangle AMP, cos theta equals to A by AP. Cos theta equals to A by AP. So that implies AP equals to A by cos theta. A by cos theta or A secant theta. So AP is equals to A secant theta. Now similarly from triangle PLC, sin theta equals to B by PC or PC equals to B by sin theta. So it's equal to B cosecant theta. B cosecant theta. So AP is equals to A secant theta, B equals to B cosecant theta. So this we can write it as A secant theta plus B cosecant theta. So here A and B are given distances, so that is a constant. So this can be treated as a function of theta, L of theta. Now we will differentiate this. So L dash of theta with respect to theta, so it will come as A secant theta tan theta plus B into derivative of cosecant theta, that is minus cosecant theta cot theta. So now L dash of theta equals to 0 implies A secant theta tan theta minus B cosecant theta cot theta equals 0. So this is equals to 0. So that implies A secant theta tan theta equal to B cosecant theta cot theta. So that implies A by cos theta into sin theta by cos theta equal to B by sin theta into cos theta by sin theta. That is converting everything in terms of sin and cos. So this will become sin cube theta by cos cube theta equal to B by A or tan cube theta equals to B by A. So that means the critical point is tan cube theta equal to b by a, or tan theta equals to b by a to the power 1 by 3. Tan theta equals to b by a to the power 1 by 3. So now we'll find the second derivative. We'll find the second derivative, L double dash. So it will come as a into, this is using with respect to theta, so using product rule. So it will come as secant cube theta plus a into secant square theta into tan theta sorry, here it is a into secant theta derivative of tan theta, that will come as secant square theta, so secant cube theta, then a into derivative of secant theta, that is secant theta into tan theta, so it will come as secant theta into tan square theta, secant theta into tan square theta, so secant theta into tan square theta, then minus b to cosecant theta cot theta, so the derivative will be cosecant cube theta, so it will become plus, because cosecant theta into derivative of cot theta will be minus cosecant square theta, so it will become plus. Similarly, it will become plus b derivative of cosecant theta, so that will become cosecant theta into minus cosecant theta cot theta, so it will become cosecant square theta into cot theta. So this is the second derivative. Now we can show that this derivative is less than 0 when tan theta equals to b by a to the power 1 by 3. So tan theta b by a to the power 1 by 3. So the length is maximum. Length is maximum when tan theta equals to b by a to the power 1 by 3. B by a to the power 1 by 3. So now we will find the maximum length. Okay, maximum length, that is length is a secant theta plus b cosecant theta. So tan theta is equals to b by a to the power, that implies cot theta equals to a by b to the power 1 by 3. So now you'll find the length, maximum length, it is a secant theta plus b cosecant theta. So this is equal to a into secant theta is square root of 1 plus tan square theta plus b into square root of 1 plus cot square theta. So this is equal to a into square root of 1 plus b by a to the power 1 by 3 whole square, so it will become b by a to the power 2 by 3 plus b under root 1 plus a by b to the power 2 by 3. So the maximum length is a into square root of a to the power 2 by a 1 plus b by a to the power 2 by 3. Then here b the square root of 1 plus a by b to the power 2 by 3. So this, if we simplify, it will become a square root of a to the power 2 by 3 plus b to the power 2 by 3 divided by a to the power 2 by 3 plus b into square root of a to the power 2 by 3 plus b to the power 2 by 3 divided by b to the power 2 by 3. So this is under root is there, under root, here also under root. So now a to the power 2 by 3, when it comes outside the root, it will become a to the power 1 by 3. So this will become a to the power a divided by a to the power 1 by 3. So that is a to the power 2 by 3 square root of a to the power 2 by 3 plus b to the power 2 by 3, then plus b to the power 2 by 3 under root a to the power 2 by 3 plus b to the power 2 by 3. So now this one under root a to the power 2 by 3 plus b to the power 2 by 3, that is taken as common. So this will become a to the power 2 by 3 plus b to the power 2 by 3 to the power 3 by 2. So that is obtained if you take a to the power under root a to the power 2 by 3 plus b to the power 2 by 3 as common, then it will become a to the power 2 by 3 plus b to the power 2 by 3 will come outside. So that means it is a to the power 2 by 3 plus b to the power 2 by 3, a to the power 2 by 3 plus b to the power 2 by 3 half to the power half, then a to the power 2 by 3 plus b to the power 2 by 3. So that means this will become 1 plus 1 by 2, so it will come as 3 by 2. So that is what we are asked to prove. The maximum length of the hypotenuse is a to the power 2 by 3 plus b to the power 2 by 3 whole to the power 3 by 2. That's all in this video. Thank you.